Yeah, the recording has started. Savita, it's all yours.
Okay. So hey everyone, today we're going to look into how to do message queuing with RabbitMQ. So the agenda is going to be, we'll do an introduction where we'll go over some concepts and terminologies used in this queuing world, and then also see a little why and when you should be using queuing as your solution to the problem. And then we'll look at a quick look at the setup and install. It's like pretty easy. It's very simple. But there was like one gotcha when I was installing on Windows. So that's why I just wanted to include this section. And after that, we'll jump into the code and demo. We'll kind of switch between code and demo. So what I'll do first is I'll first do a very small hello world basic program. So we kind of understand the concept of how a message is sent to the queue and how it is read. And after that, we'll do a little more detailed coding. So the next is, so concept and terminologies, right? So RabbitMQ, it's basically a message broker or like a queue manager, right? It's an open source messaging software, message queuing software. And it's written in Erlang, a language which is more widely used in telecommunications. And I think Ericsson uses it or it came up with it, I'm not too sure. But that's the language that RabbitMQ server is written in, right? And then, so RabbitMQ is one of the queuing softwares, but there are like other queuing softwares also. So AWS has SQS, which is simple queuing service, and Microsoft has its own MSMQ. IBM has its own IBMMQ. And then there's also Kafka from Apache, which is more for streaming kind of messages. So in that case, Kafka is more helpful and useful. And so RabbitMQ, when it initially came about, it used AMQP protocol. So there are a few queuing protocols, and RabbitMQ started with AMQP, but now it supports like few other queuing protocols. Like there's another protocol called MQTT, which is message queue for telemetry transport. And it's mainly used for mobile devices. It's very smaller footprint, and it's also used in those IoT devices like Internet of Things. And then there's also another protocol called STOMP, which is Simple Text-Oriented Messaging Protocol. So all these protocols, they just have their different rules and how message should be formatted and what is the handshake and the initial connection, all those things. But we'll look into AMQP for now. Now let's look at some of the terminologies and get familiar with the queuing software. So the broker. So first thing is the broker. Broker is basically, if someone says broker in the queuing world, it just means like the RabbitMQ server, right? That's the message broker. That's handling your message, like what to do with the message, which queue to put it in, when to deliver, how to push, pull, all those things. So your RabbitMQ server, which holds the queue, that's the broker. And queue, of course, is the queue, which will hold all your messages. And publisher is the one that's going to write to the queue. So that software is called a publisher or a producer or a sender, someone that's going to send message to the queue. And then on the other side of the queue is your consumer, which will read messages from the queue. And these publisher and consumer, they talk to the queue through something called channel, which is kind of a mini connection. So you form a connection, the producer consumer, they'll make a connection to the broker, and then within that, they will make channels, right? So channels are kind of mini connections, and you don't want to keep creating new connections because connection is a little more resource intensive. So you make a bigger connection to the RabbitMQ broker, and then each producer consumer, they'll start making individual channels to the queue. All right, so those are like kind of basic concepts. So you have producer, which sends messages to the queue, and on the other side, consumer, it'll read those messages from the queue. Now, why and when would you want to use a queuing scenario, right? So the main idea behind queuing is one of the one of the ideas is decoupling your system, right? So instead of having one huge monolithic system, you can split your logic into a producer and a consumer. So a producer is only going to be responsible for creating your messages, and then consumer can take care of how to process those messages. So if you can break your system into those two separate pieces, then it simplifies coding. And then now that you have two different producer and consumer systems, if for whatever reason producer goes down, your consumer doesn't have to go down. You can still work on the producer, bring it up, and if the same happens with consumer, your producer can still keep sending messages to the queue, and they'll stay in the queue until a consumer is ready to pick it up. So it kind of helps in that sort of performance to resiliency, right? And one key thing behind queuing is your processing is in the background, right? It's asynchronous. That's the idea. So if there's some process that you can do in the background and you don't need immediate response, then you would use queuing. Like say, for example, you have a site which is going to generate like a 40-page PDF form or a report or something, and that takes around, I don't know, like 5 to 10 minutes. So what on the client side, the user can just say generate PDF, and then the user can continue working on other part of the website while this report is being generated. So this message will be sent to the queue, and then in the background, the consumer picks up the message, processes it. When the PDF is generated, it can generate an event or however you want to handle it, and then it can respond back to the, you can send a response back to the client. I mean, the consumer directly won't send, but you can have some other process which will handle that. All right. So in that case, we'd be using queuing, right? So next, let's just quickly look into setup and install. So in the past few sessions, we have realized that there are several ways to use a new app that you want to start working on, right? So the simple and the first thought that comes to my mind always is install the software on your local, right? That's how we have been doing in the past. But then we got this concept from Docker, containerization. So you can download a Docker image, run that software as a container, and it doesn't like disturb any part of your machine. You don't have to install new softwares, new libraries, nothing. You don't have to format anything on your machine. So you can run it as a container, within a container. Download the Docker image, and you can run it as a container. And then the third option, of course, is running it on the cloud as a service. So in MongoDB, we ran it from local, then we created a Mongo container, and then we also had the option of running the MongoDB on the cloud. So similarly, the RabbitMQ can also be run these three different ways. And the cloud version of it, if you want to create an account, is called Cloud AMQP. So you go to that website, create an account, and then just create an instance. It'll give you a RabbitMQ instance, and then you can start using from there, right? But for this demo purposes, we are going to run a local version on Windows. So you can install it on your local machine as a Docker container or just like RabbitMQ itself. And I'm kind of pointing this out only for Windows because on Mac it was like pretty straightforward, but on Windows I had to keep this in mind that I had to first install Erlang. So you need to install Erlang first, then install RabbitMQ, and then this third step, that is optional. That is, I'll show you why that step is optional. It depends on you. So I am going to come out of this presentation, and you see the second link. This is the link we'll go to right now. It has some install instructions. Do you still see my screen?
Yes.
Okay. All right. So to install on Windows, you go to that website. That's on the PowerPoint. So you first install Erlang, right? And it'll give you all the steps out what to do. It's pretty simple, straightforward. You just click and follow the steps one after the other. And then you install RabbitMQ, right? Again, it gives the step. It takes you to the RabbitMQ website. Click on installer, go to that exe, download, run, and it'll start running. And then this is the third step, which I said is optional. So RabbitMQ, until this step, RabbitMQ is running as a server. But now if you want to look inside the server, you want to perform some operations or you want to get some statistics. So that's what this management plugin is for. And this management plugin, it's the UI version of it, right? So you can see it on the browser. But if you are like more of a command line kind of a person, you don't need that. The RabbitMQ install, it'll provide you all these management tools through a command line also. But if you want to see it on the UI, then you have to enable this plugin. And how you enable that plugin is you go to this directory, sbin, where it got installed, and then you run this command, right? So after you run this command, your management plugin is enabled. So this is why that step is optional, okay, and it depends on you. And how that management plugin looks like is like this. So by default, RabbitMQ runs on port 5672, and its management plugin runs at this port 15672. Right? So you can go here and you can look at your RabbitMQ server. It's in the overview. You can get some statuses. You can look at certain things, and there's a queues tab, which will list all the queues that you create, right? All the queues that get generated. So right now it says there are no queues, but we're going to create some queues there. All right, so now that's the setup and install, right, management queue. All right. And then, yeah, let's go into the basic code and demo, right? So in this basic code, what we are going to do is I'm gonna kind of rewrite this code again, just so you see, but I have it there in case I mess up, there's some typo, I have it running. So there are, okay, so let's see here. So the way I have it set up is a consumer folder and a publisher folder. So publisher is the one that's gonna write to the queue, and consumer is the one that's gonna read from the queue. So we start from writing to the queue, which is publisher. And let me cd to publisher, so I'm there. And so you can just start by creating a folder and then just do npm init. It'll create your package.json and you'll have your kind of a node project, right? And then within that, like for now, you can just ignore all of this. You'll just create a file, send.js, but I'm going to call it send2.js. And before that, you do npm install amqp lib. So this is going to get the amqp lib package from the npm registry, right? So you'll have that package and it'll get installed on your project. So this is the JavaScript library that we're going to use. That's going to provide us the methods that we want to use to connect to RabbitMQ, create channel, create queues, send messages, all that thing. So since I've already done that, I'm not going to do that. So now to create a queue, start writing to the queue in RabbitMQ, these are the steps. These are the basic steps, right? You first have to connect to the RabbitMQ, the broker, and then you create a channel, which is kind of a mini connection, and then you create a queue. And once you have the queue created, then you can send message to the queue. And once you're done sending message, you just close the connection, right? And it's pretty simple. And I'll later on show you that their website, RabbitMQ, they have very, very good tutorials. So all this code that you're seeing here, it's all like copy pasted from there.
Savita, one quick question, if you don't mind. Mm-hmm. What would be the difference between channel and queue? I may have missed if you had explained that earlier.
So queue is the one that's going to hold your message, and channel is the one through which the publisher is going to write to the queue. Okay. So you need a connection to the queue, right? Because they're all separate systems. So your publisher is one system, and then your RabbitMQ broker that's sitting in some other server, mm-hmm. and then your consumer is a third system. Okay. Now you want to connect, right? Just like client server, you need a HTTP connection first, right?
Yeah.
Right. So that's what channel is.
Thank you. Thank you so much.
Okay. All right, no problem. All right. So our first step is connect to RabbitMQ. So this AMQP library if I can type it right, AMQP. So this library, this is what it is, right? This is what the AMQP library is. We imported it, AMQP/callback.api, right? And okay, before I go there, and the local host where my RabbitMQ is running, that's here, AMQP/localhost. And since 5672 is the default port on that, and this is the AMQP protocol, so it knows that's the port, right? So that's my connection. That's how I'll make the connection to the RabbitMQ through this URL, right? And just to be sure, let me just run this. All right. Okay. So I'll make a connection, AMQP. It provides a connect method, and then you pass it the URL to which you want to connect to, which is our AMQP localhost. And then it has a callback function, which is going to return you the error in case something happened, and it will return you this connection object, which will have the connection that got created. Now, that's all you need to make a connection to the RabbitMQ server. Now we'll just do a little bit of error handling. So if there is any error, we're going to just throw that error, right? So we'll do that. And after we have made the connection, so we're done with this step. Let's close the connection after we are. So I'm just going to put this code here for now first, because anything else that we do after making connection, we'll put it somewhere here on line 17, 18 in between there. So let's just close the connection. So the way to close the connection is, and I'm going to close the connection after like a second of making the connection. I'll give it some time. So for that, you just use this set timeout, which again takes a callback. And within that callback, I will connection.close. You just close the connection, and we exit the process successfully. So this set timeout, it takes this callback function, and then it takes a second argument, which is like, run this function after how many seconds. So I'm going to run it after 1 second. It's in milliseconds, so 1000 milliseconds, which is 1 second, right? So I just want to run it real quick to make sure. All right, so it does close the connection after. All right, so our first step was creating a connection. Our second step is create a channel. So how do you create a channel? So you create a channel on the connection. So we got that connection object here, right? This connect method, it returns us the connection object. So on that connection object, it provides a method called create channel. And create channel, again, takes a callback, and then it'll return you the channel that it created. And I'll do the same kind of error handling here a little bit. Right. So we're done with step 2. We created a connection. We created a channel. So our next step is to create the queue. So to create the queue, we create the queue through this channel, and this channel provides us assert queue. This is the way to create the queue. And this assert queue is, it's an, what is that called? Idempotent method that you can run it again and again. So if the queue doesn't already exist, it'll create one. And if it exists, it just doesn't do anything, right? It's already there. So it'll create only if the queue doesn't exist. So the queue that we want to create, so assert queue, it takes the queue you want to create, the name of the queue, Let's just put it in a variable. And I am going to call it my sample queue. All right, so this one, assert queue takes queue, and then it takes some options, right? So the options are, there's certain options on the queue, like you can set some queue properties. For example, one of the things that we're going to set is durable. Durable will set it to true. So as the name suggests, durable means it's going to stay across the, in case your server shuts down or it crashes. So when your server again comes back up, that queue will exist. But if you say durable is false, and if you shut down your server, then your queue is going to go away, right? So it writes to the disk and it maintains it, kind of like it persists it. So durable is true. So I think that should be enough. So we created the queue. I'm going to code just only this first part, so it might seem slow. And once we have the queue, then we can send the message to this queue. The way we send the message to the queue is, we again use the channel object that we got, and we say send to queue, right? And then the send to queue, it takes the queue that you want to send the message to. So we want to send it to this queue, which is my sample queue. And then it takes the content you want to send, which is a buffer object. So we're going to do buffer from, and I'm going to call it message, and I'm going to create that variable. So const message is equal to hello world to my sample queue, right? We'll send this message. And this should, if I have coded it right, this should send the message to the queue. And I'll just console log, so we see it here on the console that we have sent. So I'm going to send message to this queue, right? So after it is sent the message, it'll print this. Now let's just cross and right. And then once we are done, we had already closed the connection. And we just give it like 1 second to close the connection. All right, so if I have coded it all right. All right, so before that, before I run this, so we see there are no queues here, right? So if this works fine, node send to.js. All right, so it says that send message hello world to my sample queue. So now let's go and look here. See, there were no queues earlier there, right? And now we see that our sample queue got created. And then it has one message. You see these messages? So this lists the messages that are in the queue. And we see that there is this message. There's one message there. If we send another message, if we run it again, there'll be 2 messages. And now if you want to go look into some details of this, so you click on that queue. This is why this management tool is so helpful. It's like right there. So you can click on this get messages. And then if you click get message, this is the message that's sitting in the queue, right? So you see it here. All right. Now, if you say we want to send another message. So hello world to sample queue again. We'll send that message, right? So let's just run it again. All right. Now it says it sent this message to the queue with again. Now let's go and see what's here. Now it says there are 2 messages, right? So it's just as simple as this sending messages to the queue. And again, if you go here, so messages, so if you say 1 here, it's giving you only the first message. But if you want more messages, you just say 2, or you can just say 5. You know, you don't know how many are there, but you know that There are less than 5 messages, so you just do that, and you see these 2 messages, right? This was our first message, and then we send this message again, right? So that's how we write to the queue. All right. So this was our publisher program. Now let's see how we read from the queue. So to read from the queue, I'm going to go to this receive queue. And these are the steps you need to do for reading from the queue. So it's basically the first 3 steps are the same. You, of course, have to make a connection to the broker. And then you have to create a channel so you can talk to the queue and create the queue. Then you create the queue. And then instead of sending to the queue, you read the message from the queue. So what I'm going to do is I am going to just copy paste this whole thing, because we have part of the code here already, right? And we don't want to close the connection here because our consumer needs to be listening on the queue. And so we connected to RabbitMQ, we create a channel, and we create the queue. And again, here you have to keep in mind that your queue name is the same because this is the queue you want to read from. So that's our queue. And now instead of sending the message to the queue, we want to read from it. So the syntax for read is also pretty simple. So on that same channel that you created, there's a method called consume. So you want to consume from the queue. And what this consume takes is which queue you want to consume from. So you want to consume from this queue. And then it has this on message method. So as soon as there's a message, the broker sends a message to the consumer. This is the method you'll use for that. So function, and this MSG message, this is the message that your consumer got from the queue, from the broker, like kind of broker or the queue. You could say it either way. Now you have this message, and so now let's just console log it, just to see what that message is, right? So I'm gonna console log received from, I'll just put this queue name, received from queue, and this is the message I received. So the message that you get, that's an object, so it has all the other information. But if you just want to see the payload of it, that text that we sent, so it's message.content, and then we're gonna just do string, right? All right, so we don't need this. This was part of our send, so we're not sending to the queue, we are actually reading from the queue. So I'll just put this comment here. Okay. And we're done with all these 3, right? Because we copied from. Now let's see, if I have written this right without any syntax error or anything, then they should run also. And again, this receive method, I have put it in the consumer folder, right? Because it's, I mean, ideally it's a totally separate system, but here you just see it all together. So I will cd to consumer. So this should have my receive too. So I just run. So right now we see there are 2 messages here, right? So once I read from here, .js, so it read both the messages from the queue, right? Hello world to my sample queue, hello world to my sample queue again. And now if you go back here, oh, I forgot one thing. So you see unagged, the message hasn't been acknowledged. So I forgot to give it one parameter, which is when you read from the queue on the consume method, so you see there is a queue, and then there's a message, and then there's this options. So in this options, the 3rd parameter is the options. So in the options for now, we're going to say no ACK is true. So what this no ACK means is, I I'll also explain this more in a later in my later code. But basically, what this means is what NOAC true means that the broker is not looking for any acknowledgement from the consumer that it got the message and it processed, and the broker can remove the message from the queue, right? So we are saying as soon as the consumer gets the message, as soon as the broker has sent the message to the consumer, it can be deleted from the queue. So that's like another way that it kind of RabbitMQ maintains the, what is it called? The guarantee of delivery, that it's going to wait until the consumer says, yes, I'm good with the message, you can remove it from the queue. So in case the consumer doesn't send the acknowledgement back, the broker is going to hold on to it if we had said this, NOAC is false. So NOAC true means, I don't care about your acknowledgement, I'll just remove the message from the queue, right? So I had missed that step, so I am going to stop this. And let's see what this does here. And this management UI, it has like a 5-second refresh, right? It takes 5 seconds to refresh. And now you see how the message was unacked. So it didn't remove it from the queue. It just put it back because I killed the consumer connection to the broker. So when I did a Control-C here, so that queue lost that consumer, right? So there's no consumer connected to this queue. So what that broker did was all the unacknowledged message, it put it back in ready again. So I still have those 2 messages available. So it's not like losing your messages if you don't send the acknowledgement. So if I run this again, all right, so it read the 2 messages again. And now let's see here. All right, see, it went from 2 messages to 0 because the consumer read the message and it considered it read and successful. Now the messages are gone from the queue. So I'm gonna stop this. So that's how you read from the queue. So this was like the straightforward write to the queue, read to the queue. And these steps are simple, like we see here. Connect to RabbitMQ, create channel, create queue, and the send message, right? And the same thing on the receiver side too. All right, so now, so this was like the basic example. Now let's go back to the slide. All right, but like in real life, it's not going to be as simple as this, right? It's never this simple. So in the earlier slide, we saw, I'm just going to scroll here. Where is it? This one, right? We just saw that there is a publisher, there's a consumer, and there's a queue in between. Publisher writes to the queue, consumer reads from the queue.
Hey, Savita, can you go into present mode?
Oh, okay.
Thank you.
All right, good. You still see my screen?
Yeah.
Right. Yeah, thank you.
All right, no problem. So, so really behind the scene, it's a little bit more involved and more complicated than that, than a simple publisher consumer and publisher queue and a consumer. So there's this concept of exchange, which is kind of a, your router. You're kind of a routing agent for these messages. And so the broker has this exchange, and it could have multiple exchanges. But let's, for the simplicity's sake, let's say broker has one exchange, and then there could be multiple queues. So right now we just created one queue, but this exchange could have multiple queues, and these queues are bound to the exchange through something called a binding key. It's just like a simple text. It's not like your public-private key. That's not the key here. It's more like a, your routing address kind of thing. So the queue is going to be bound to the exchange through something called binding key, and then the publisher is going to send messages to the exchange. So publisher always sends messages to the exchange. It never sends it to the queue. For simplicity's sake, I just shown it that it's sending it to the queue, but it goes to the exchange, and from the exchange decides where to route this message to, like which queue it should go to. So, and the queues are bound to the exchange through a binding key, and the messages are going to have something called routing key. So depending on what the routing key is, the exchange is going to send that message to that particular queue. So wherever the routing key matches the binding key. So in this example, say the message that the publisher sends, it has a routing key called Q1, right? And so when it comes to the exchange is going to look like whose binding key is Q1. So it is Q1. So that's where that message is going to go. But if there's another message which is Q2, it'll go to the second queue. So that's like a concept of exchange, binding key, and routing key. That's how it behind the scene actually works. And now these exchanges, there are like a few different kinds of exchanges. The most simplest one is the direct exchange. Then there's a fan out. Fan out is like the exchange is going to just send the messages to all the queues that are bound to it regardless. So that's a fan out. It's more like a broadcast. And then there's like topic exchange. There is header exchange. And they're like, you can do more granular, like a pattern matching kind of a thing. Or you want to send it to these 2 queues, but not to these 3 queues. So you could kind of do all that detailing using the type of, by changing the type of exchange you're using, right? And then we briefly saw this concept of acknowledgement. So in the code that we saw so far, we said the broker is not going to care for acknowledgement, but ideally you want to care for acknowledgement, right? Say the consumer is processing a message and for whatever reason it fails, or it loses the connectivity, or there could be any reason, or message is not valid. So then there are different ways to handle that, like your message processing failure. So how do you handle that failure? So if the message is good, processed fine, everything was fine, then the consumer can send an acknowledgement back to the exchange. So once the exchange gets the acknowledgement, then only it will remove that message from the queue, right? And then there's also this concept of if the message wasn't right, like consumer thought there was something wrong with it, there are different ways depending on your use case, your scenario. You could just like, if the message is not valid, I just don't care, I just delete. Then you still send an ACK, but you do nothing with the message. But for whatever reason, if you want to save that message, you can requeue that message. Like you can reject it instead of acknowledgement. You say you reject it, and then you requeue it to either back to the same queue, or you can requeue it to something called like a dead letter exchange. We won't go too deep into the dead letter exchange, but just know that dead letter exchange is a way of handling your message processing failure. So the basic concept is it's like another queue which will hold this message that failed, which kind of died. Those messages will be held in this queue. And then on this queue, you can put different rules, like after the message in this queue will stay for 2 days, or it'll stay for 5 days. And from this, there'll be another consumer which will read from it, and it'll say write it to the database, or maybe do further processing or anything. So it depends on your use case, how you want to use it. But you can do those settings. Like for this queue, the dead letter exchange is this. DLE is the dead letter exchange for this queue. So when you reject the message, then that message will automatically go to this dead letter exchange, and it'll go sit in that queue, depending on the routing key that you have set, right? So it's a little more detailed, but just keep that in mind. There is this concept called dead letter queue to handle failed messages. So that was requeuing also, right? Dead letter queues. And so there's something called queue properties, also queue arguments. So queue properties, we saw durable, true, and there are a few more queue properties you can set. So that's queue properties. And then there's also queue arguments, where you can set these additional arguments on the queue, which you might find helpful or you might not, but it depends. But there's something called queue arguments. We'll also look into one of the queue arguments just to see how to use queue arguments. And then there's something called queue priority. So queue priority is, so by default, these queues are FIFO, like first message in, first message out. But for whatever reason, if you say that, say in this example in Q1, you want to process M3 before any other message, right? So when you're publishing it to the queue, you'll set the priority higher for this message. So then what the broker is going to do is as soon as the consumer is finished processing its current message, it'll send M3 because it has higher priority than M2. So it'll send that message first, or it'll put that message in front of the queue so that message gets picked up. I don't know internally how that queue priority works, but that's the idea. So, so this is like a real life consideration that you may run into. All right, so now let's do a little coding example for this one. All right, we'll start with the send. I'm going to clear this. So we have to come back to publisher. Okay. So in this one, I'm not going to code everything. All right, so this is another, I just wanted to show you real quick. So the URL we connected to earlier for our local host was that URL. But say, for example, if you're using Cloud AMQP, your RabbitMQ server is in the cloud, then this is your URL will kind of look like this, something like this. So you see this piece, this string before the colon, that's your user ID. And this one, until the @ is the password. And then this is your host. So this is kind of like similar to how we did in MongoDB. We created a MongoDB instance on the cloud, and it gave us this connection string. And it will be very similar in RabbitMQ Cloud too. It will give you the string. You just copy paste here. So instead of URL local, you just use that URL, and everything else is the same, right? But we won't do that for now. We'll still stick to our local. So the new concepts here that we saw is, all right, so in the earlier demo, we didn't specify the name of the exchange, right? So if you don't specify the name of the exchange, there's something called, so these are the exchanges that were installed by RabbitMQ. When you installed RabbitMQ, you didn't have to do anything, right? So there's this AMQP default. So if you don't give it the exchange name, that's the exchange that'll take care of routing your messages to the queue. So this was the exchange that our message went to earlier. And now you see there are like different kinds of exchange. Direct, fan out, headers, match, topic. Oh, I missed the match, right? So yeah, there are different kind of exchange, and you can kind of Google more details of what each of these means. But basically fan out is a broadcast. Headers is like, there's something in the message header you can put, and you could look for that to route it to a specific queue. Match is, I think, pattern matching, and topic is something similar too, but there's still some difference. So right now, these are the exchanges that were provided by RabbitMQ itself, and we had used the default because we didn't use a name. So now what we're going to do is we're going to create our own exchange, right? So we'll create our own exchange, and we'll create 2 queues on that exchange. We'll bind 2 queues to that exchange. So through that, we'll see this concept of binding key. And then the message that we send, that needs to have a routing key for it to tell which queue to send that message to. And then we'll also look into how to pass these additional queue arguments. So again, here, the code is the same. You connect to RabbitMQ, you create a channel. And now instead of creating the queue, we'll first create our exchange, right? Again, it's like similar to how we created the queue. You say assert exchange. Again, like kind of similar properties on the exchange. Durable is true, that it'll survive across your server shutdown or crash or anything. And auto delete false. That means don't automatically delete this exchange. So what that means is like if there are no publisher or no consumer listening to this exchange, then just delete this exchange. But we don't want that, right? We want our exchange up all the time. But there are cases, in some cases, you might want like, I want this exchange only as long as someone is listening to it. Once no one is listening, I don't care, right? So we'll use these properties on this exchange. So what this assert exchange takes is the name of the exchange you want to create and the type, right? For simplicity's sake, here we'll create a direct exchange. But you can replace this with fan out, headers, match, and then accordingly, like whatever you use, your syntax here in the lines below will change a little bit, but we'll keep it direct here for simplicity. All right. So we created our exchange, then we'll create a queue and we'll bind that queue to that exchange, right? So creating the queue, same method, assert queue, and the queue that you want to create. And then these are the properties that we are sending to the queue. And then we also talked about this, it can take additional arguments, right? Queue arguments. That's how you're going to pass arguments to the queue. So we're creating one argument here called X message TTL, which means messages time to live. So in this queue, you can control how long the message is supposed to live in the queue. So here I'm saying it is supposed to live for 30 seconds. Again, it's in milliseconds, so 30,000 milliseconds. So any message that we send to this queue is going to live for 30 seconds in the queue. And after that, if within that 30 seconds, if no consumer reads it, that message gets deleted, right? So you can create all these rules on the queue, like either it gets deleted or it gets sent into another queue, like a dead letter queue, or you can handle it anyway. But in this case, we're just going to say after 30 seconds, just remove it from the queue. Default behavior is just remove, right? Just leave the message in the queue only for 30 seconds. So that's the additional arguments. Oh, and just real quick here. So these arguments, if you don't know what arguments it takes, you can go to this management, RabbitMQ management, go to queues, and then click on this add new queue. And then you'll see these arguments, right? And if you click on this question mark, it'll tell you that if you want to send the message, set the message TTL, then this is the argument you have to use, X message TTL and auto expire. So you'll use X hyphen expires. So you'll get some help from here. Because sometimes it's hard to Google these things, right? Okay. So we're going to set only one argument, TTL, but if you want more, you can just keep adding more here. All right. So we create the queue. Q1, it's durable, auto delete is false, and these are the arguments we're passing. And then it returns this callback function, which if there is error, it'll error out. And then it returns the queue that got created. Now, once we have the queue created, now we want to bind it to that exchange. So for that, you say bind queue. It's a method on the channel. So channel.bind queue, give the queue that you want to bind, and to which exchange do you want to bind it to. So give the exchange name, and then you give the binding key. So this is the binding key that this queue is bound to the exchange. And what is my binding key here? My binding key is this, right? I have kept it same as the name of the queue. I mean, normal convention is you just keep it same as the queue name, but you could call it anything. Depending on if your logic requires something, you can change this name. But I'm just keeping it same as the queue name. So that's my binding key. And then it takes some optional options, which I don't have anything to set, so I'll just say null. And then there's this callback. I'll do a little bit of error handling. If there's some problem in the binding, then I'll see it here. So once the queue is bound, now we can send the message to the queue. So we saw that earlier, the way we were sending message to the queue when there was a default exchange, we used the send to queue, right? But instead of that, now we will use publish. So publish to this exchange, use this routing key. So what is my routing key here? Routing key is the same as the binding key. And this binding key is for that queue. So this message is going to go back to my Q1 based on this routing key. And then just the message that you want to send, right? So I want to send this message. And then there's this optional options that you can pass. So I'm saying persistent true. So this is a similar concept of durable true. So persistent true means if you want to, again, the message will survive between the server crashes or server shutdown. So this is I created one queue on that exchange. And I just created a second queue on it's the same code, exactly the same code, just the values are different. And then the TTL here is 60 seconds. So in the second queue, the message is going to live for 60 seconds. all the other code is the same. It's just that my binding key is different, my routing key is different, so it goes to that particular queue. So now if we see, like if you go here, we have our original sample queue. Now if we run this one, it's in publisher. So I'll do node and advanced JS. So it sent these two messages to two different queues. Now if we go here, so it created those two queues, advanced 1 and advanced 2, and it sent one message each, right? We send one message each. And now you see in our advanced queue, this is the argument we passed. It said that TTL is 30 seconds. For the second one, TTL is 60 seconds, right? So you can pass different arguments to the queue. And within 30 seconds, this message should go away. Like if we don't do anything, if there's no consumer. So you see that message went away after 30 seconds. So that is that time to live. And like in another 30 seconds or so, this message will go away too, because its TTL is 60 seconds. So yeah, it'll go away. We can come back and look at that. And oh, it's 4 o'clock, right? I just have one more concept to explain. Which is on the, so these were the concepts on the sending the message side, right? Now on the receiving side, we saw that we can pass the acknowledgement, right? Instead of saying the broker doesn't care about the acknowledgement, we will send, the consumer will send the acknowledgement. So again, it's the same thing, you know, connection, create channel, create queue, and this is the acknowledgement. So what I have done is, ideally, when you're processing a message on the consumer, it doesn't just process in a second, usually because it's a background process. The very reason we put it in the background, because it takes longer to process. So all we are doing here is we are setting, like we're just adding this fake processing time, like 10 seconds, and we're using that same set timeout function, that this message will get acknowledged in 10 seconds, right? And we set our no app to false. So basically what this means is the broker is going to expect an acknowledgement from the consumer. Until it gets an acknowledgement, it's not going to remove the message from the queue, right? So that's, so you have to change this flag, and then you have to send the acknowledgement. This is how you'll send the acknowledgement for that message. So for this, and this is my queue 0. So I haven't created that queue, so let me quickly create that queue. I think my send, yeah. Node. So it doesn't like this. Cannot find module consumer send.js. Oh, sorry, not send, it's receive, right? We're reading from the queue, sorry. So now node receive.js. So the only reason I'm running this is I want to create this queue, my queue 0, which I need in my next. All right. If we go here, we have this queue created, right? And we saw that this message went away after 60 seconds, right? All right, so now we have that queue. So in the receive advanced, so we're going to send the acknowledgement, and then there's this also this concept of prefetch on the channel. So what prefetch means is that controls the number of messages that the broker will send to your consumer. So prefetch 1 means it'll send only one message, and until it doesn't get the acknowledgement back from that consumer on that message, it's not going to send you the other message. So right now we say prefetch as 1, right? So now okay. So this is another way to publish to this queue. I'm just going to publish from here. Hello world 1. So let me see. Okay, so I have 1 message in my queue. I'm going to go ahead and publish a few more. So I'm just taking a shortcut here. Instead of running my program, I'm just publishing directly from this management. 4, 5, okay. So I have 5 messages here. It'll, for in a few seconds, it should show 5. Okay, so 5 messages. So now I prefetch of 1. I'm going to open another bash here. So what I'm planning to do is I'm planning to run 2 instances of this consumer. And consumer. And we want to see, so if I do node, receive advanced, right? It's going to get 1 message at a time, and it's going to take 10 seconds to process. Let me also start another consumer here. Right. So you see on the left side, it got first message, it processed, took 10 seconds, and it got the second message. Meanwhile, the second instance of the consumer started, so that got the third one. And while it was processing, because the broker still didn't get a message, the acknowledgement back from the consumer, so it didn't send the next message to this consumer because it was waiting for the acknowledgement. So you see, if you're running 2 instances of the consumer, so this is if you deploy it as a container, you can scale the consumer up, that you're going to be running 2 instances of the consumer. So then you can process those messages in parallel, right? And if your queue load is super high, then you can run, say, 5 consumers. So 5 consumers would be working on those messages. So you see how alternatively they processed. On left, it's message 1, 2, 4, and the one on the right got message 3rd and 5th, right? So that's what prefetch 1 is. Now let's try if I don't have that prefetch. So if I don't have that prefetch, I don't know what this is. So by default, if I don't say prefetch 1, so what this does is, let's first publish a few messages to this queue. So hello world 1, I'm going to publish this. Hello world 2, 3, 4, 5. Okay. So I published 5 messages, I think, but it shows maybe okay, 5 messages, right? So now if I clear this. Now if I start the consumer here, now I've commented out the prefetch. So if I do this, you see it got all the messages, and then it starts to process it. So now this, if you're running a second instance of the consumer, that's just sitting idle. It has no messages to process. So that's where your prefetch comes very handy, that you want to distribute your messages among different consumers. So it'll help you parallel process, improve the performance, and it'll help you do that. So the 2 concepts we saw here, I mean, you couldn't really see how the ACK worked, but like if I had commented this out, the message will still sit in unact, like how we saw earlier where I had forgotten to put that flag, right? So your message was still unact. So basically that's the concept. All right, so we saw this, and I think, all right. I think so that's all with the code and the demo that I wanted to do. And then I put this next slide here. It's like just some companies and some projects that are using RabbitMQ. So JP Morgan, it uses RabbitMQ, and it kind of processes about 1 billion messages per day. NASA uses it, Google, and India's Aadhaar project uses RabbitMQ. And there's this Ocean Observatory initiative by NSF. And these companies, Red Hat, Mozilla, VMware, Warner Media, all these companies, they use RabbitMQ. There's just some examples. There are many more companies that use RabbitMQ. And that's it. So if you have any question and answer, I just put this text here because I found it kind of just puts what RabbitMQ is in a small, like in a few sentences. But you don't have to read through it. I just put it there. But if there are any questions.
Good job, Savita. Very well done.
Thank you.
Very
Yeah.
informative. Thank you.
This was very informative.
Thank you. Yeah, this RabbitMQ, it's
great.
oh, thank you very much. Because this one, RabbitMQ, this is like very, how do I move this? Okay. So this RabbitMQ website, this is very, very, very helpful. So, so if you go to the tutorial, so I go to RabbitMQ, and then there'll be a get started. So get started brings you here, and then you go to this tutorial, right? And it looks long, but it's a very easy read. And that's where I got all that initial basic code. So this is where I got the hello world code from. Then the next concept is the work queue, where you have a fan out exchange, and you have multiple consumers reading from the same queue, and then a publish subscriber model. And how do you want to handle routing, right? Say if you have a direct exchange on certain instances, you want to route it to a different queue, then how to deal with topics exchange, then RPC, publisher conforms. So we saw acknowledgement came only from consumer, but you can also, there's also something called, even publisher can get a confirmation from the broker. Like the publisher sent the message to the broker, but how can publisher make sure that the message actually got to the queue? So there's something called publisher conforms that you can look here. So you just pick the language you want to do it in, and then just follow the tutorial. So for example, I'll go to the JavaScript, right? That's where I went. So you go here, you read through this. It's very nice. It looks long, but it's a very easy read, not hard at all. And here's the whole sentence. So if I go to this one, if you open this link, how do I get, oh, okay, I can do this.
Like you can close one of your tabs and then or use another tab to open it.
Okay.
Okay, yeah.
I'll do this. All right. So yeah, so I clicked on this one, right? Send JS script. And I just like copy pasted the code from here. This is what you saw in the first, when we did that small hello world send to queue. This is that same exact code. We just saw it step by step. First you connect to the queue, then you create channel, and then you create the queue, and then you send to the queue. So these tutorials, they are like very, very easy to understand. So if you are looking into starting to work on queuing, read through RabbitMQ, then just go to their website, go to tutorials, and then just pick the language. I mean, you could be C# or Ruby, Python. They have all these examples. It's like, the website is excellent. That's it, guys. Oh, and then this cloud AMQP, like if you had your, like how we had MongoDB on the cloud, you could also create an instance on the cloud of RabbitMQ, and you see this is the connection string it gives you. So you just like copy paste, and then if you go to its manager, it's the similar interface that we saw on the local. So if you create a queue using that URL from RabbitMQ, from Cloud AMQP, your queue will get created here. So it's the same management UI is the same.
So Savita, based on Rupak's comment, do they have the syntax in ES6 script? Like JavaScript, it's like the older.
Yeah, they do actually.
In the same. Okay.
The same library has async await functions.
Okay.
I put a code snippet on the chat window.
Yeah, I saw that.
Okay.
That's why I asked if it's there in the website, or do we have to search for that?
I don't see it here. The JavaScript that they show here, that's not ES6, right? They're using function and all that.
Yeah, look in the NPM library.
Okay.
So if you look for the AMPQ library that you used, if you go to NPM, you'll see that they have the library, the code samples there. But the same commands that you use or the functions that you use, the same, those don't change really.
Yeah.
So it just becomes simpler because you don't have to nest all those callbacks.
Yeah, I think if we have async await, Yeah. Is this where you were?
Yeah. You see, well, that's just the example of not the ESX example, but if you keep going, actually, I did just a Google search.
Okay.
Okay.
I just did a Google search on AMPQ lib async, and it kind of popped up a guy's gist, and I picked it from there. But you can just use the same functions, but you don't have to. You just put await in front of it. Everything else should work same as it.
Same as that. Okay.
Yeah. As that. Yeah.
Oh, and so that reminds me, like you're talking about async await, right? So there is another thing. Is say if your consumer loses the connection to RabbitMQ, then I mean, if we are doing a test and trial, we're experimenting, it's fine. But in like real production system, you want to have some reconnection logic, right?
Yep.
So there is some library, JavaScript library also available for reconnection logic. Like if your server breaks after 5 seconds, if it loses the connection, it'll try again, and it'll say try every 10 seconds for 3 times, 5 times. You can set all that value. So that reconnection logic, that also would be, I think, available in async await kind of thing.
Yeah, sure.
Right. So that's like another concept of you want to have some sort of reconnection logic if you lose connection to the server.
Yeah, and I also put the Docker Hub link to the RabbitMQ image if somebody wants to take a look at it. That's a homework for you.
But, how do I see the chat here?
Oh,
so
just
there is
on the top, I think.
No, on the bottom, like right next to.
Oh, yeah, I see. Oh, okay, yeah.
I really love the way you explained the prefetch. That's a very important concept.
Right.
And the DLQ, the dead letter queue.
Dead letter, yeah.
Yeah. And for AWS lovers, SQS and Kinesis is two different queues. Kinesis supports both static and streaming as well.
Oh, okay.
Yeah, so if you want to play around with it. Like there's production grade, highly scalable queues without you doing anything from the infrastructure side.
So SQS is one and Kinesis is one, right?
Yeah, they're different, yeah.
Use one. Okay, right, okay.
Yeah. SQS has become kind of obsolete because it's a little expensive now because everyone is kind of using Kinesis because it's highly available and most of the people are using that now. But yeah, it's a good place to start with your free tier. It's available, so.
Okay. Yeah, I mean, initially, like few years ago, SQS didn't have many, like it didn't have too many features as RabbitMQ had. So people would pick RabbitMQ, and it's very well done. But I think SQS now, recently it has caught up a lot, but I guess they put in more effort in Kinesis, right?
Yeah, so they're two different products. So if you remember when SimpleDB came out, it was just like SimpleDB. And then they came up with DynamoDB. So it's two different target audience. So SQS is like, if you want to just do really simple stuff, like, you send a message and you just want to process it, it doesn't have too many frills, but it works, right? Without knowing all the, complex concepts of queues. But then once you kind of use that and then feel the need for graduating to a complex architecture, then you just move it to Kinesis. So I think that's what the thought process was. But like after DynamoDB got famous, they took down SimpleDB. I think that's gonna probably happen with SQS as well.
Right.
Yeah.
And AWS, they keep adding services and features to their, so it's like always updating. So if you don't have something now, if there's enough support in the community, or if they have enough need for it, they will bring it. So
yeah, it's very consumer feedback based product side.
Yeah.
Like just one of those, like that's one thing I love about AWS. I mean, just very consumer centric. Yeah. But yeah, it was great. Great presentation. I loved it.
Well, thank you.
Yeah.
All right. If no more questions, then we'll see everyone next week.
Okay. Thanks, Savita.
All right. No problem.
Thank you, Savita.
Thank you,
great.
Savita.
Awesome.